So for the first part, we're going to measure the flow rate coming through each leg of the parallel circuit. And unlike before with the series circuit, we're not going to use the flow meters because we would need 2 of them for each group. And just like because of limited resources, we're going to use a different method. So instead of the flow meters, we're going to measure how much water actually flows into a graduated cylinder within 20 seconds. So right now I only have 1 cylinder and it's pretty small. This is only 400 milliliters. You're going to want something considerably larger, like maybe 1,000 milliliters. But you definitely need it to be a graduated cylinder so you can measure how much water comes out. So to do it, you're going to have one student hold the parallel circuit above each graduated cylinder, and then another one timing 20 seconds. And as soon as the time is up, you just remove it and put it above your basin again. So to demonstrate that for you now, since I don't have 2 graduated cylinders, I'm just going to use this tub. So because you'll still be concerned with air bubbles within your piping, you'll want to hold it above your basin before you put it above your cylinders. So this will probably get a little bit wet in between transferring it to the cylinders and then back, but that's okay. So what your students should find is that the amount of current flowing through the side of the parallel circuit with the shorter resistor is greater than the one with the long resistor, because with the shorter resistor there's less resistance, so more water can flow through it. So to add on to this, now we're going to connect the 2 ends of the parallel circuit together again so that we have one current flowing out. And what your students should find is that the current flowing out from here is the sum of the 2 currents flowing out from each side of the parallel circuit. So now we're going to measure the pressure drop before and after each resistor in the parallel circuit. So like I said before, pressure here is analogous to voltage. So you can see that in my setup, I have the inlet coming in here, and this is my outlet. And my voltage meters are after each resistor. So there's multiple ways of designing this, and I would encourage your students to be creative. You could use this, and then they would have to figure out how to place the voltage meters before the resistor. So what we found in the previous experiment where we were measuring the flow rate was that the current going through each leg of the parallel circuit was different. The one with less resistance had more water flowing through it. Here, when we measure the pressure or the voltage across each leg of the parallel circuit, we'll find that it's the same. So I just turned on my circuit, and it took a little while to get all the air bubbles out, so I would just have patience with that. And also, a couple times the pipes came loose, so before you turn on your circuit, make sure that they're really secure. But as we can see, the voltage after each resistor is about the same, which is what we would expect. So what we found before in the series circuit was that the pressure drop across each resistor was respective of its length. So for a longer resistor, you have a larger pressure drop. Here we see that we again have 2 different size resistors, a longer one and a shorter one, but that the potential drop across both of them is about the same. So why is that? So what we also found when we measured the flow rate through the series circuit was that the current after each resistor was the same. So throughout the entire circuit, the current was the same in each leg of it. But what we just measured with the parallel circuit was that the current flowing through each leg of the parallel resistor was different. So even though you have 2 different resistors, you also have 2 different currents flowing through it. And those 2 factors come together to produce the same voltage drop across each leg of the parallel resistor. So for the last part of the experiment, you can have your students make their own circuit. So they can play around with the resistors in series and in parallel. They can play with the size of the resistors in terms of their diameter or their length. And in addition to that, you can think of other challenges for them and see how that they approach them with the tools that they've learned. Thank you so much for watching this video. If you have any questions, please feel free to contact Cornell X-Rays. And when you're doing this experiment, be sure to have fun with your students. This is a really messy lab, and I'm sure that you saw throughout the video I had varying degrees of water across the table. My advice to you is just you make sure that everything is well connected before you turn on the power source, and that you have plenty of buckets and towels at the ready.